I was strolling on the moon one day in the merry, merry month of December. May.
More than 35 years have passed since humans last walked on the moon. NASA's current mission is to once again take a giant leap for mankind by establishing a human outpost on the moon. To pave the way, robotic missions surveying the moon will launch in late 2008.
The Lunar Reconnaissance Orbiter, or LRO, and the Lunar Crater Observation and Sensing Satellite, or LCROSS, will launch together on an Atlas V rocket.
Their mission is to provide critical information to NASA as it plans our future on the moon.
We here at NASA Ames Research Center are extremely excited to be designing and conducting the LCROSS mission. The goal is to determine if water, perhaps in the form of ice or hydrated minerals, exists inside a permanently shadowed crater on the south pole of the moon.
Water is an extremely valuable and versatile resource. Water can be split into hydrogen for rocket fuel and oxygen for breathing. It can be mixed with moon dust to make concrete used in building shelters. It also makes an excellent shield to protect against radiation. Since any ice on the moon might be buried underneath a layer of rock and dust, we need some method of getting the ice out into the open and detecting it.
The LCROSS mission accomplishes this with 2 space vehicles. The Centaur upper stage of our moon rocket will be used as a 2,200 kilogram kinetic impactor, excavating a crater approximately 20 meters wide and almost 3 meters deep. More than 250 metric tons of lunar dust will be lofted above the surface of the moon.
The shepherding spacecraft, built by our partner Northrop Grumman, guides the Centaur upper stage to the target. It also carries cameras, spectrometers, and a photometer to analyze the debris plume to look for the presence of water vapor, ice, hydrocarbons, and hydrogen, which is one of the components of water.
The science instruments on board the LCROSS spacecraft cover an extremely wide spectrum. We have spectrometers that can see organics, hydrocarbons, and byproducts of water ice. We also have infrared cameras that can see hydrated minerals, water ice, and water vapor. In addition to telling us if water exists on the moon, the science that comes out of this data will be used for many years beyond the LCROSS mission.
3, 2, 1, 0, and liftoff.
2 hours after launch, LRO will separate from LCROSS and continue on its way to the moon. 5 days after launch, LCROSS and the attached Centaur will execute a flyby of the moon. They will then enter into several large looping orbits around the Earth for the next few months of the mission. We will use this time to check instrument calibration and refine our trajectory for lunar impact.
About 7 hours before the impact, the shepherding spacecraft will separate from the Centaur and position itself to observe the impact at the south pole of the moon. For the next 4 minutes after the impact of the Centaur, we will receive real-time data as the shepherding spacecraft flies through the plume and scans the ejecta for signs of water.
The shepherding spacecraft will then impact the moon, creating a second plume of lunar dust.
Both impacts will be closely observed by professional astronomers on the Earth, using some of the world's greatest observatories. We also believe there is a chance that the impact plume may be visible in 10 to 12-inch telescopes. We are encouraging both professional and backyard astronomers to participate and contribute their observations to this exciting mission.
We are at a key point in human history. Humanity is preparing for its next stage in our development, and that stage is settling the solar system.
As NASA moves forward with our exploration programs, one of the most important things we need to figure out is how people can live for long periods and eventually permanently off the Earth.
If we can identify water ice at the poles of the moon, we can use that water to live off the land.
We are excited, proud, and honored that the LCROSS mission has been chosen to be a first step on our long journey as humanity takes our next giant leap back to the moon, to Mars, and beyond.